In this video, we will learn how to use data to find a best fit line for quadratic functions. Again, a quadratic function in standard form is going to be ax squared plus bx plus c. Ax squared is considered the quadratic term, bx is considered the linear term, and c is considered the constant term. And note that a cannot equal 0, because if a did equal 0, 0 times x squared would give you 0, leaving you with a linear equation. Now, when you have a table of values, sometimes it may be difficult to figure out what type of equation could the table of values represent, whether a constant, a linear, a quadratic, or an exponential, which there are others, but these are the 4 that we are going to discuss today. So the first table, this is actually considered a constant function. If you look from the y values from 3 to 3, it adds 0 each time. 3 plus 0 is 3, 3 plus 0 is 3, plus 0 is 3. This would be what you considered the slope. It is constant. And so you would have y equals 0x, and then what your y value is will be your answer. So the constant would be y equals 3 in this case. Now in the next term, if I figure out the difference between each y value, 3 to 7 is a difference of 4. 7 to 11 is also a difference of 4. 11 to 15, 4. And 15 to 19, 4. This again, because the first difference is the same, then we would also say that this can be our slope. And this is what we would call a linear function. And it is going to be y equals 4x plus b. And then if you plug 2 and 3 into your x and y values, you'll be able to figure out your b term. So it would be 4x minus 5, because 4 times 2 is 8. And to get from 8 down to 3, we had to subtract 5. So this would be considered a linear because the first difference is the same number. And when I say that, this is what happens when it's not. So in the third case, to go from 3 to 13, it is a difference of 10. But from 13 to 29, it is a difference of 16. From 29 to 51, it's a difference of 22. And 51 to 79 is a difference of 28. Now, this set right here is not the same number like it was here, a slope of 4, or here a slope of 0. It's not, which means this cannot be a linear or constant term. So you need to go one more. So find the difference between these points. From 10 to 16 is a difference of 6. From 16 to 22 is a difference of 6. From 22 to 28 is a difference of 6. Because we had to go to our second row, I guess you could say, or our second time out of finding the difference between the numbers, this is what actually makes it a quadratic. And so we know that this is going to be in some type of form of ax squared plus bx plus c. And then this video is actually going to show you how to figure out a, b, and c. And then last, if we were to go from 3 to 6, it's a difference of 3. 6 to 12, it's a difference of 6. 12 to 24, it's a difference of 12. 24 to 48 is a difference of 24. And so if we go a second time, 3 to 6 is 3. 6 to 12 is 6. 12 to 24 is 12. And so I'm still not getting a constant. If we keep going, from difference of 3 to 6 is 3, difference of 6 to 12 is 6. So anytime I keep going out, I'm not finding a constant number. So this is not going to be a linear or a quadratic. Instead, this is actually an exponential. I realize that if I multiply by 2, 3 times 2 gives me 6. And if I multiply by 2, 6 times 2 is 12. If I again multiply by 2, that is how I get the next term. So this is going to be considered an exponential, which would be in the form of y equals a times b to the x. And b is going to be 2 to the x, because that is the term that you're multiplying each time by. And then you would plug in an x and y in order to find your a term. And so if I plugged in 2 for x and 3 for y, I will actually get 3/4 for a, so therefore my equation would be 3/4 times 2 to the x. But in this video, we are going to be discussing how to find a, b, and c. And I'm going to do it by a calculator. Okay, so I'm going to pull up a graphing calculator to determine how to find the quadratic, what we call a regression line of these points. And so what I'm going to do is I have my set of points. I'm going to go to Stat, and I want to edit my list. So I'm going to hit Enter. And so when I go to List 1, if you have numbers in your List 1, if you go up and highlight the actual name of the list and then hit Clear and Enter, it will automatically clear the whole list. So I know that my numbers are 2, 3, 4, 5, and 6. And now I'm going to click the arrow over, and for my list 2 is going to be 3, 13, 29, 51, and 79. Okay, and now from here, now that I have my list for list 1 and list 2, now I can go back into Stat. I'm going to go over to Calc, and I want to figure out my quadratic regression, which is going to be number 5. So either you can just click 5 or go down to 5 and hit Enter. And they're asking, like, your calculator may or may not show this part, but it's basically asking is, hey, are your X values in list 1? Are your Y values in list 2? So I'm just going to click Enter for all of these, and I'm going to hit Calculate, and there's my answer. So A is 3, B is -5, and C is 1. So therefore my equation is 3x squared minus 5x plus 1 would be considered the quadratic function based on that data. So we're going to do it one more time. Find a quadratic based off of this data. The x values is going to represent time, and the y value represents height. Because think of independent and dependent variables. Time is independent, and the height is based off of that time. That's why it becomes dependent. So that is why x and y would be here. So pull up your calculator again. So I'm going to go to Stat. I'm going to edit. Now you can either edit over these numbers, or you can go up, hit Clear, hit Enter, and it will clear out the entire list. So now I can click on 0, 1, 2, 3. And then I'm going to go over, and I'm going to clear my list, and then type in the numbers. Okay, now that I've done that, I'm going to go back into Stat. I'm going to go over to Calc, and I want to figure out the quadratic regression line. Hit Enter, and there are your numbers. -16, 33, and 46. -16, 33, and 46. So first, I have found the quadratic model. And now they want to know, we want to use the model to estimate the height of the ball at 2.5. So I can take this and I can plug in 2.5 to find my answer. So I'm going to go back into my calculator. I'm going to do -16, 2.5 squared plus 33 times 2.5 plus 46. And I will get 28.5. That means the height of the ball is going to be roughly about 28.5 feet in the air at 2.5 seconds.